Good morning. In today's session, we are supposed to study about the bipolar encoding. This is the type of line encoding. We are saying there are different types like unipolar, polar and bipolar. In unipolar, we are using only 0 and 1 value. In polar, we are using +1, -1 and 0. And in bipolar, as the name define, here we are supposed to use two values. These are nothing but 0 and 1. So 1 we can represent for positive, and if we are using 0, that will be transmitted by no pulse. It means what? 0. So here we can say about the bipolar encoding. Bipolar encoding, we will use here 3 levels. This will be 0, positive and negative. But unlike return to 0, the 0 level in bipolar is used to represent binary 0. And 1 level we can represent by alternating positive or alternating negative. It means what? Here, if there is no pulse, we can use 0. And if there is a pulse, that will be positive or negative, depending on whether the previous value that was transmitted by that signal, we can assign value 1. It means what? Here, if we are using the value binary 0, there will be 0 level. And if there is alternating positive or alternating negative voltage, at that time we are supposed to use binary value, that will be 1. So here, a common bipolar encoding scheme we can say as a alternate mark inversion. The word mark will comes from the telegraphy and it means 1. So here we are saying bipolar signaling रहेगा, bipolar encoding रहेगा या फिर AMI. AMI is nothing but we are saying alternate mark inversion. All are having the same meaning, or we can say this type as a pseudo-ternary. It means what? Here, if we are using the 0, it means what? There will be 0 level. And 1 we can represent by alternating positive or alternating negative value. +1, -1, or we can say plus A minus A. So this is the alternative mark inversion. The name pseudo-ternary is because here we are using the 3 levels: 0, 1, -1. So it can be return to 0 or it can be non-return to 0 type, and it is the advantages over the RZ NRZ polar because it will not have DC component, and it eliminates the ambiguity that may arise because of polarity inversion. So here we can see the waveform for the bipolar, or we can say alternate mark inversion encoding, or we can say this as a pseudo-ternary because here we are using +1, 0 and -1, 3 values. So we can see here the ones are positive and negative alternatively. If you see, if it is going pulse, we are taking, if it is going above, we are taking 1. If it is going negative minus high, we are taking 1. And if there is no level, 0 level, we are taking its value as a 0. So here you can see the frequency spectrum of the various types of modulation schemes. You can see normalized frequency, that will be on x-axis. We are taking mean square voltage per unit bandwidth, that will be on the y-axis. So you can see here the waveform for the non-return to 0L, non-return to 0I polar encoding, AMI bipolar encoding, Manchester and differential Manchester encoding. So here we are saying the bipolar encoding, or you can say a bipolar signaling, that is nothing but alternate mark inversion, that will be same, but here alternating positive and negative pulses occur for binary 0 instead of binary 1. If we are talking about the pseudo-ternary is nothing but pseudo-ternary, if you are calling, that will be the same bipolar, but pseudo-ternary, that is working as a AMI, but here but alternating positive and negative. If there are alternating positive and negative pulses, we can take that for binary 0. और हम सूडो टर्नरी में क्या ले रहे थे, वहाँ पे हम 1 ले रहे थे, तो यहाँ पे इंस्टेड ऑफ बाइनरी 1 वी आर सपोज टू टेक बाइनरी 0. एंड हियर also we will have 3 levels, 0 plus 1 minus 1. Here also no DC component, but it will require less bandwidth. And here as we will require long sequence for 0, because we are taking for positive and negative pulse, we are taking the value 0, so there will be longer sequence of 0. So we can say it will loses the synchronization for the longer sequence of 0. If we are supposed to calculate the modulation rate, we can say that can be expressed in a baud rate, and you can derive modulation rate. Modulation rate we can denote by letter D. So we can calculate D equal to R by B, where D will be modulation rate. We can give the unit watts. R is nothing but data rates that can be measured in the beat per second, BPS. And L is nothing but the number of signal elements. So you can take D equal to R by B, or if we are not having the value of B, you can calculate that as R upon log 2 L. L is nothing but number of signal element. So if we are calculating the modulation rate, you can calculate minimum and maximum. You can see here we are having the maximum for differential, and the for Manchester we are having the maximum modulation rate, that will be a 2. Here we have finished about the different types of line coding technique which we are supposed to use over a baseband digital transmission. The difference between these we will see in the next class. Thank you.